Hello everyone, my name is Yanan, a doctoral student in Geospatial Information Science Department. Thanks to all of you for joining this virtual talk. I'm really excited to share with you my research. The topic of my poster is spatial-temporal analysis of traffic accidents in Dallas. Vehicle as one of the most way to move people and goods. While they help us, they also threaten our lives. Researchers estimate 37,000 people were killed in traffic accidents in 2018. Unfortunately, this number is still increasing. World Health Organization predicts that traffic accidents will rise to fifth leading cause of death by 2030. So it's important for us to understand where and why they occur and how we manage them. Location characteristics usually lead traffic accidents, like the round interaction and the freeway junction. Bad weather like a rainy day will influence road condition. Spatial and temporal pattern is like a cube. The X and the Y correspond to location of traffic accident. The vertical axis is the temporal. It could be hour, week, or year. We study traffic accidents in Dallas. This city is a ninth popular city in the United States and also ranked as the ninth most dangerous city for drivers. We use traffic accident data from 2010 to 2018. Another data is point of interest POI. It's a point file with the location of features on the Earth. Like the map shown here, different icons correspond to different features like a bank or store. The attribute table shows the specific information stored in POI like name and address. We extract the traffic accident in every hour on every day of the week. For example, 6 hours on Monday correspond to traffic accident occur from 6 to 6:59. So there were 168 groups in total because 24 hours per day and 7 days per week. We use buffer method to analyze spatial and temporal pattern. Considering road system in Dallas, we create 750-meter circular buffer for each accident location. Then we wanted to find out the location with high frequent accident. So we compared the buffer in each year. For example, the first layer, the buffer is created based on 8 a.m. Monday 2010. Then we go to check the buffer in the same location but created in 2011. Then we continue to check next few years until 2018. Next, we analyze the location characteristic around dangerous location. For the dangerous location, we identify them as persistent reoccurring location. We extract and summarize POI within each dangerous location, and we use the a priori algorithm to find the association rules between features and the location. So based on the rules, we could find out the features that together around persistent recurring location, or when some location gather around one location, how likely this location is dangerous location. Based on data and method, we found interesting spatial-temporal pattern. First, for the temporal pattern, the weekday and the weekend show different pattern. During weekdays, we found that dangerous location usually occurred in the morning from 6 to 9 a.m. and afternoon from 4 to 6 p.m. However, it's different on weekend. The persistent recurring location usually occurs around early morning, around 2 p.m. during weekend. The spatial pattern for the weekdays. Before 4 p.m., we found that most of the dangerous location located around the northern part of Dallas, especially around I-635 and I-75. After 4 p.m., we found that the location started to spread along the I-35 towards the southern part. During weekend, Saturday and Sunday show the similar pattern. Most of the cluster gather around I-35 around this part. So it's an interesting pattern because those 2 days not only have the similar temporal pattern, but also have a similar spatial pattern. So we need to go to check the geographical environment around them and to find out the reason. Before we run the a priori algorithm, we use the contel method, divide the number of POI into different groups. So the lowest level, level 1, to highest level, level 2, correspond to less features and more features. For example, store level 1 means there are 5 stores around accident location. Store level 2 means there are 15 stores around accident location. The first figure is a rules based on the persistent reoccurring location. Each line represents each rules. We found that entertainment, nightlife, and the store have a strong association with the dangerous location. We also create a rule based on the location with a low frequent accident and the location without accident. We found that these rules based on the 2 locations are related with lower level instead of higher level. So based on the result, we have several conclusions. The weekday and the weekend have a different pattern. From Monday to Friday, the commuting time has a high frequent accident. Entertainment, nightlife, and the store usually have a strong association with persistent recurring location. So in the future, this pattern could help government to manage traffic accidents and also calculating the dispatch route for the 911. This pattern could help driver to avoid dangerous location in every hour, so the emergency car could arrive destination within the required time.